Okay, where were we? We were talking a little bit about ggplot. Now, ggplot is a library, a package they're called in R, that provides a lot of additional function. As I said at the beginning of the first kind of little mini video, R works by having a set of base functionality and then having these additional packages that kind of install on top. And ggplot is one of the big ones. This is, very widely used for creating graphics. It's incredibly flexible, but it's also not the easiest thing in the world to learn. I promise you now that you will get frustrated with ggplot, but it is like the standard way of doing our graphics. Now, what am I doing here? Basically, I'm saying require tells me, let's just put in require, basically checks if ggplot is loaded, if it's installed. If it's not installed, then we install it. So don't worry too much about the syntax. This is just standard code you kind of paste in if you want your code to work automatically. And once the package is installed, you use the library function to use it. So when I use the word library, it goes straight into memory. So now let's use ggplot to actually create some histograms. Now what we're doing is when you call ggplot, you first give it the name of the data frame. Then you define AES, which defines your data. And here I'm saying, okay, I've got my X variable, I'm going to call is the math quiz, and then I'm going to fill by major. I'm going to do a histogram. There's a function called geom histogram. I'm not going to set the number of bins, I'm going to set how wide there are. So we have a new histogram bin every 5. And scale fill brewer, this just determines the colors that you use. And theme black and white, if you don't do this, the background's gray. We don't like gray backgrounds. So that's kind of a lot in one command. And I don't expect, for this homework, you're just going to be tinkering with a few things. But there's a huge amount. There's books on ggplot and how to do ggplot graphics. So it's kind of something that's useful to know. So let's have a look at this. So there we have the histogram. It's filled by major. I don't like that. As an analysis, to show you how to use the function, it's okay. But as an analysis, it looks a bit like a dog's breakfast. We can also have different, we can change the histogram. We can set more parameters. Instead, as well as bin width, we can actually have the position. And the position just tells you what sort of histogram we're going to do. We're going to have a fill histogram. And there we go. For each kind of bin, we can actually see the proportion of majors. Now, I guess you can see the, the very high scores. There's a lot of pre-meds. There's also a psychology student. And some of the biology students are maybe not doing quite so well. And then we have a third one. This time, rather than fill, we use dodge. And that just kind of, dodge just means they're separated out. They're kind of next to each other. But again, in terms of inch, I wouldn't want to put this sort of graph on a business report. So what I'm doing now is, and I'm not going to explain every single step, I'm going to do something called a population pyramid. And I'll just show you what a population pyramid looks like. And this is a population pyramid. And basically, we're getting the frequencies of scores by gender. So we're comparing males versus females. So this is actually, though it was designed for population, you'd have the ages on the y-axis. It's actually pretty useful if you want to compare two groups. If you say wanted to compare users or non-users of a certain software product, what sort of satisfaction they have, or something like that. Now, I was hoping maybe that nobody had actually written this function in the last year. Otherwise, all this code would be pretty much useless. But this just kind of goes to show. I just wanted to do this example because it shows that R can do anything, but it's not necessarily easy. This was something that was a point-and-click option on SPSS. So I'll just kind of quickly go through it, but you don't have to understand this. I think I have an exercise where I just get you to copy and paste it. Basically, I set up my breaks. The sequence function tells us to go from 0 to 100 by n. So it just creates a list of where my breaks are manually. The male, gender male, I basically get all the math quiz scores for males. So I get all the ones that are not equal to NA and are actual males. Then I set kind of the cut points for a frequency table. So let's just do gender male. And we have gender male. And then the cut function kind of works with histograms. And it basically creates a set of cut points given the breaks. And it just defines from the, just defines the ranges basically of both the how we're going to do the histogram. Then I get the frequencies for each of these cut points. So I get like the frequencies. Now, why have I made the males negative? Well, that's because the males are going to be on the left, so they're going to be minus. And I do exactly the same with the females. I combine them into a single data frame. So we use data frame, we put the males, the females, and then we select the actual, there's a lot of junk with it, so select the frequency columns. Let's just see what we created here. It's been so long since I wrote this code. Just remind myself what's in this column. So that this is the cut points, basically the names of the cut points to put on the axis. Then in the data frame we say the bins and whether it's male or female. Now I'll explain this function. This is actually a useful function later, reshape function. And basically what it does is, if you look at the original fret combine, it's basically what we call it's basically got the bins, it's got the males, it's got the females. Now let's use what's called the melt function from reshape. And let's have a look, and let's just name the columns. And let's just see what it does. It basically, you see here, we've got different columns for males and females. It actually gives the frequency, and it puts the males and females in a single column. So it basically goes from what we call a wider data set, where we have males and females separate, to putting it in one column. That's what the melt function does. And then we do the ggplot function. We've got the X, the Y, and the fill. We have to design two bar charts, one for males, one for females. We define our scales with the breaks for the x-axis. We use something called coordinate flip to make sure it goes from left to right, not top to bottom. We set our palette and we run it. So really easy then. But again, for this homework, I just want you to, I don't want you to create your own. Just want to cut and paste. And this was something I thought I want to include this for the students. And I thought it's going to take me 10 minutes. In fact, I think it took me several hours, and then I wrote like a page or two of code. So again, you can always do something, but it can be incredibly complicated. Okay, so let's go back and let's get a little bit more simpler. So we have a box plot. You remember box plots from business stats? Let's just draw the box plot. And you should remember this. We have, if we look at the function, we have Math Quiz 100. That's the actual values, and we split it. We do a box plot for each different reason. So we're literally comparing scores for different reasons for taking the class. So we can see here that people with personal interest generally have higher scores than advisor, recommendation, or program requirement. Yeah. If you're interested in stats, you're probably likely to do better than, oh God, I need a stats class to graduate from college. Again, as before, we've got to put the data set. We have to put the title in main. we put our labels, X label and Y label, and we're going to color it in blue. And just as a reminder, you should all know what a box plot is from business stats. But the bottom is the minimum value. This is the 25th percentile. The middle is the median. Then the 75th percentile, and then the top value. And depending on your settings, you can sometimes have outliers. Now, ggplot can actually have a more complicated box plot. So let's just say we have the X is the reason as before. We have Y, which is our value. But now we're going to add an additional one. We're going to fill by gender. So essentially we've got, before we just had reason, now we have reason and gender. We run G on box plot, which is the ggplot box plot. And there we get a slightly more complicated box plot. So now we can compare both male and female scores by what type of reason we have for taking the class. Okay, final little test. We're going to do something called a scatter plot. And again, you should have done this in business stats. So it's just plot what we want on the x-axis, what we want on the y-axis. We're going to type in the name, which the title of the graph. PCH, you can look at this online. PCH is just the type of kind of the shape that we're using, and then we've got the labels. And we didn't actually do the plot. So there we go. We can see PCH4 gives us a star. We've got the pre on the X. We've got the post on the Y. And we can see, people who have high heart rates before the test are liable to have high heart rates after the test. You can see there's going to be a reasonable, from your business stats, if you remember the concept of correlation, there's going to be a reasonable correlation between these two variables. And we can actually add, and we'll talk more about this when we do regression, but for the moment we can just add a simple regression line on this. And there we go. This is like the best fit regression, the line that best shows the relationship. And finally, just another interesting, there's loads of different types of scatter plots. The pairs command basically does scatter plots between any variables you include in the list. So here we remember C is used to create a list or a vector, and we're just creating a vector of variables. We could have actually probably used just the numbers of the columns as well, and we're basically doing pairs. We define the data, and we set the columns from the list, and then on that we run the pairs. So we first give our list, then we have the data with just these columns in, and then we run the pairs. If you're trying to understand code, this is always a good thing to do. Take the smallest possible command, run it, then run the next thing, then run the next thing. So here we go. And whoa, that's a lot of information. Now, what scatter plots are used, if we have a lot of variables in our data, we just want to see where the relationships are. So we're going to think, is there a relationship? So we can see here, there looks like there's a relationship between anxiety base and anxiety pre. There seems to be pretty linear. And it seems to almost be kind of clustered into two different groups. Maybe these are people who are very anxious about statistics and people who are not. And again, between our different values of heart rate, you can see again, it's not like, there's this almost linear relationship between the different heart rates. You can see that when one goes up, the other guy goes up as well. Okay, and just final one little tip before we go. If you're thinking, my God, how do I ever remember all these functions? There's so much here, I'm not going to be able to. You're probably not. But one nice way of looking, if you go to our studio, there's the documentation. One nice way of finding our documentation is type in the letter R in Google, then the name of the function, and you actually can get the documentation. And you will actually you'll have documentation. If you go a bit further down, you will have lots of different tutorials on the subject. So Google is your best friend when it comes to R. Our documentation is like a documentation site that tells you about the function. It will also give you information about all the values, the parameters, and the output. It will give you some examples. This guy here, the stat.f.ch, this is like the official site, and this will give you, again, kind of the information about the technique, all its parameters, and maybe even a little bit of background. It will tell you, you know, who the authors are, where you can find more information about it, and some examples. So R is something that you really need to learn yourself, and you really need to delve into the documentation. Okay, that's been quite a lot for the first week, so we'll just